motion and time. We have learnt about the importance of measurements. The comparison of an unknown quantity with a known quantity is called measurement. When we check temperature of a body or buy clothes, measurement is done. Time plays a vital role in our daily life. For example, we go to school every morning at a fixed time. We can describe time as a lapse between two regularly recurring events. Don't we say past midday or after lunch break? Measurement of time. Human beings have felt the need to keep track of time from ancient times. In olden days, people did not have watches or clocks. They used the various events having repeated regularly to count time interval. They used the time from sunrise to sunset, the length of a shadow, one full moon to another full moon, and the change of seasons to measure the interval of time. So, if you hear your mummy saying on a Sunday to a fruit seller, "Come next Sunday," she means come after 7 days. Sundial. Sundial was the first clock invented. It is based on the movement of shadow during the day. The shadow cast by sundial was longer in the morning, reduced to nothing during noon, and became longer again in the evening. Hourglass sand clock. The hourglass uses the flow of sand to measure time. It consists of two rounded glass bulbs connected by a narrow neck of glass. The upper bulb contains some sand that streams down into the bottom bulb, giving the fixed interval of time. Jantar Mantar. This name can be translated as magical device. It was built by Maharaja Jai Singh II. The one which is present at Jaipur Observatory is considered as the largest sundial in the world. Built of local stone and marble, this sundial is 90 feet high. Its shadow is carefully plotted to tell the time of the day. This instrument was also used to observe the movements of the sun, the moon, other planets, and stars. Unit of time. There are many repetitive phenomena happening in nature. For example, the rotation of the earth on its own axis, which determines the length of the day, has been used as a standard of time. We know that a day is divided into 24 hours, each containing 60 minutes of 60 seconds each. One mean solar day equals 24 hours, equals 24 into 60 minutes, equals 24 into 60 into 60 seconds, equals 86,400 seconds. Therefore, 1 second is equal to 1 by 86,400 mean solar day. The SI unit of time is second. It is denoted by S. Other commonly used units of time are 1 week is equal to 7 days, 1 year is equal to 365 days, 10 years is equal to 1 decade, 100 years is equal to 10 decades is equal to 1 century, 1000 years is equal to 10 centuries is equal to 1 millennium. Today, time intervals of smaller fractions of a second can also be measured using electronic or digital display clocks. Some of these clocks can measure time intervals as small as 1 millionth or even 1 billionth of a second. For measuring very small intervals of time in the laboratory or in sports, we use stopwatch, which can measure accurately up to 1/10 or even 1/100th of a second. Measurement of time using periodic motion. To measure time, we need a motion that repeats itself at equal intervals. Such a motion is called periodic motion. It was Galileo, an Italian scientist, who first noticed that swinging body has a regular beat and can be used for timing purpose. For example, if you ride on a swing, the time it takes to move from one side to another is constant. The time of the swing remains the same at any time of the day or in any weather. Another significant observation that Galileo made was that the to and fro movement of any pendulum of the same length are all of the same duration of time. This principle is used in making clocks and watches. Simple pendulum. A simple pendulum may be defined as a heavy point mass called bob, a small brass or lead sphere, suspended by an inextensible thread from a fixed point and allowed to swing freely under the influence of gravity. Terms used to describe a pendulum. Number one, length of a simple pendulum. Length L is the distance between the point of suspension and the center of the bob. Number two, oscillation, one complete vibrational motion, to and fro motion, when the bob of the pendulum moves from one position and comes back to its original position, is called oscillation. In the given figure, from A to C, C to B, and B to A is one oscillation. Number three, amplitude. The maximum displacement of the bob on either side from its mean position, that is, from A to C or from A to B. AC is equal to AB. Number four, time period. The time taken to complete one complete oscillation is called its time period. Time period depends upon the length of the string from which the bob is suspended. Greater the length of the pendulum, the greater will be the time needed for one complete oscillation. Time period does not depend on the extent to which the bob of the pendulum is displaced, that is the amplitude, nor on the mass of the bob used. So for a particular pendulum length, the time period does not change and it is taken as constant. Motion, time and calculation of speed. We see many objects moving around us, such as a car moving on the road, people walking or running, boats sailing in the river, football rolling on the playground, or a bird in flight. These are all examples of objects in motion. A body is said to be in motion if it changes its position with respect to other objects with the elapse of time. The other objects which are not moving are therefore at rest. A body that does not change its position with respect to its surrounding with the passage of time is said to be at rest. When a body is in motion, there is often a need to measure the quality of this motion with respect to time. A body moves faster than another body if it travels larger distance with the elapse of the same time interval. In the same way, there is a need to measure the elapse of time between two events. Many of you board the school bus early in the morning at the bus stops in your colony. While the bus is driving past, the position of bus changes with respect to other objects like trees, houses, and lampposts by the roadside. Thus, the bus is said to be in motion as it changes its position with respect to the surrounding and with the elapse of time. Children sitting in the bus are in motion with respect to houses, trees, and other objects on the roadside, but they are stationary at rest relative to each other. The terms motion and rest are thus relative terms and are dependent on who and where the observer is. Slow and fast motion. What is the difference between walking and running with respect to time and distance? Walking takes more time to cover a distance. Running takes less time to cover the same distance. In terms of motion, we can say that walking is a slow motion, whereas running is comparatively a fast motion. The distance moved by objects in a given interval of time can therefore help user to decide which object moves faster than the other. We refer to it as speed. Speed. Distance traveled by an object in a unit time is called speed. The SI unit of speed is meter per second, m/s. Other unit like kilometer per hour, km/h is also commonly used. Speed is a scalar quantity as it has magnitude only. It does not mention the direction of motion. Speed v is equal to distance travelled s upon time taken t, or v is equal to s upon t. Different objects move with different speed. A bicycle moves at slow speed, a car moves at faster speed, whereas an aeroplane moves the fastest. So the speed of an aeroplane is the highest as it can cover a particular distance in the shortest span of time. We can define speed as the ratio of distance covered to the time taken by a moving body. Measurement of speed. Speed is measured as distance traveled in unit time. Popularly, it is measured in miles per hour and kilometers per hour when the speed is more. The time is conveniently reduced as speed of sound in air is 343 meters per second. Speed of light is 29 crores 97 lakh 92,458 meter per second. Calculation of speed. Let us see the following example. The distance between Delhi and Jaipur is 250 kilometers. Car takes 5 hours to cover the distance. Calculate the speed of the car. Given distance traveled by the car is equal to 250 kilometer. Time taken to cover the distance from Delhi to Jaipur is equal to 5 hours. Therefore, speed v is equal to distance traveled upon time taken is equal to 250 upon 5 is equal to 50 kilometer per hour is equal to 50 into 5 by 18 meter per second is equal to 13.89 meter per second. Note, to convert speed given in kilometer per hour to meter per second, you can multiply the answer in kilometer per hour by 5 by 80. Since 1 kilometer is equal to 1000 meters, 1 hour is equal to 3600 seconds. Therefore, 1 kilometer per hour is equal to 1000 meters upon 3600 seconds is equal to 5 by 18 meter per second. For example, 36 kilometer per hour is equal to 36 multiplied by 5 by 18 meter per second, that is equal to 10 meter per second. Similarly, to convert speed given in meter per second to kilometer per hour, multiply the answer in meter per second by 18 by 5. For example, 25 meter per second is equal to 25 multiplied by 18 by 5 kilometer per hour is equal to 90 kilometer per hour. Uniform and non-uniform speed or motion. Uniform motion or speed. The motion of a body is said to be uniform if it covers equal distance in equal intervals of time, no matter how small these time intervals may be. Suppose a car travels down the road at a constant speed of 10 meters per second. It means that it travels 10 meters distance in every 1 second. Non-uniform motion or non-uniform speed. The motion of a body is said to be non-uniform if it covers unequal distances in equal intervals of time. In a day-to-day situations, we rarely find cars moving at uniform motion speed on the road because of heavy traffic, bad roads, and traffic signals. The speedometer and odometer fitted in dashboard of cars, lorry, buses, and other vehicles display the prevailing speed and distance traveled by the vehicle. The speedometer reads the speed directly in kilometer per hour, while the odometer reads the measure of distance moved by the vehicle in kilometer. Average speed. The average speed of a body is the total distance traveled by the body divided by total time taken to cover this distance. While traveling in a car, you may have noticed that it is very difficult to keep the speed of the car uniform because at many places brakes are to be applied to slow down or to stop the car due to various traffic conditions. Average speed is equal to total distance traveled divided by total time taken to travel that distance. For example, for a car which travels a distance of 120 km in 3 hours, the average speed is 120 by 3 is equal to 40 km per hour. This does not mean that the car had been moving at this speed all the time. Plotting and interpretation of graph. The advantages of representing data on a graph paper are: number one, data becomes visual, easy to understand, and easy to remember. Number two, what a graph states can take pages to explain in written text. Number three, intermediate conclusions can be drawn. How to plot a graph? Take a sheet of graph paper. You will see that it consists of big squares of 1 centimeter into 1 centimeter. These squares are further divided into smaller squares of 1 millimeter into 1 millimeter or 2 millimeter into 2 millimeter. Now draw two lines at right angle to each other. A horizontal line OX drawn near the bottom of the graph paper represents the x-axis, whereas a vertical line OY drawn at the left end of the graph paper represents the y-axis. The point of intersection O of OX and OY is known as the origin O. The independent quantity is shown along x-axis and the dependent quantity is shown along y-axis. Furthermore, we provide a numeric value for an object location by placing it either in the positive plus direction, that is from origin towards right OX for x-axis and upward OY for y-axis, or the negative minus direction by extending XO to the left and YO to downward. The negative figures are then plotted on the extended lines. Choose a scale to represent on the graph. For example, if we have to represent a time duration of 60 minutes, we may take 1 centimeter is equal to 10 minutes on x-axis. Similarly, 1 centimeter is equal to 5 km can be represented on y-axis. Mark the points of observation on the graph with respective x and y coordinates. Now join all the set of values in the graph with a fine pencil. The graph thus plotted represents distance-time graph. The data gives the distance covered by a car in a hilly terrain over a period of 60 minutes. The reading on the odometer is recorded at an interval of every 10 minutes. Distance traveled by a car in a hilly terrain. Time in minutes. Reading on odometer in kilometer. Distance covered kilometer in different intervals of time. 0, 1200, 00. 10, 1202, 02. 20, 1209, 07. 30, 1214, 05. 40, 1216, 02. 50, 1220, 04. 60, 1225, 05. Distance time graphs. The previous tabular data can be represented on a bar graph or on a line graph. Let us compare distance time graphs of cars moving at a uniform speed and non-uniform speed. For every equal time interval of 10 minutes, a car has traveled equal distance of 5 km. For every equal time interval of 10 minutes, the same car has traveled unequal distance of 2 km, 4 km, 2 km, 6 km, 10 km and 6 km respectively. If the distance time graph is steadily rising as a straight line, it indicates that the object is moving at a uniform speed, that is, it covers the same distance in equal intervals of time. If the distance time graph is a curved line or a zigzag, it indicates that the object is moving with a non-uniform speed, that is, it covers unequal distances in equal intervals of time. We can also conclude from figure that A. Change in slope of the distance time line graph represents change in speed of the car. B. Portion of the distance time graph with same slope represents uniform speed during that time interval. A distance time graph showing how a car travels for 200 km. The slope of the distance time graph gives the speed of the object. Between 0 and 10 seconds, the object moves from 0 to 50 meters. Speed is equal to 50 meter minus 0 meter upon 10 seconds minus 0 seconds is equal to 5 meter per second. Signs in the vicinity. Every day the sun appears to rise in the east horizon. This is basically because our earth rotates from the west to the east. Had the rotation of the earth been from the east to the west, we would be having sunrise on the western horizon. Overtaking a slower moving vehicle is quite common, particularly on the highway. We should always overtake from a safe distance, from the correct side, and with enough margin of space. One should remember that when vehicles move in the same direction, the relative speed is very much reduced. Ants move along a particular pattern because they release pheromones. However, unlike other ants, desert ants don't use pheromones, smell trails, to navigate between their nest and a food source. This is because the chemicals of the pheromones evaporate very fast from the hot desert sand. The desert ants are adapted to use sunlight to find direction on their way back.